Servus. Well, that's the way we say hello in Austria. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, here we are doing binomial theorem, and I'm sure you must have studied the earlier lectures and also having good amount of practice with all these sums. Now, here, children, today we will be discussing how to find out the middle term in a binomial expansion. I'm sure till now you people know that when we talk about the expansion of 1 plus x, or say some x plus a raised to the power n, then the total number of terms which are there are actually n plus 1, right? If n be an even number, then n plus 1 will become equal to odd. And if n is an odd number, then n plus 1 will become equal to even, right? Now, children, here let's quickly try and understand that if we have some small finite number, then how do we find out the middle term or the middle terms, right? For that matter, let us first consider that we have, say, some 5 numbers, right? So for that matter, let's say we talk about the numbers to be 1, 2, 3, 4, 5, right? Now, all of these numbers have been written in order. So in order to find out the middle term, what you do is we will now be segregating the first 2 terms. We will be segregating the last 2 terms. So as such, the one which is left behind becomes the middle term. Or in other words, we can say that if we remove the first 2 terms from the beginning, and if we remove the last 2 terms from the end, we will have got the middle term. Similarly, children, let's say we have 9 number of terms in place of 5. Again, 9 is an odd number, right? So if you remove 4 terms from the beginning, 4 terms from the end, then obviously the middle term is going to be the 5th term, right? That means we have 4 terms on either side of the 5th term, right? So this is how we find out the middle term and in an odd number of terms, right? And which term does become the middle term? That then will be given by adding 1 to the total number of terms which are there and dividing by 2, right? This is for a simple data. Now let's say now here we talk about a binomial expansion. Let's say we talk about it to be, say, some x plus a, which is whole raised to the power n, and let's say here we are for sure that n is going to be an even number. So if n is going to be an even number, then if we divide this even number by 2 and add 1 to it, then that is going to give us the middle term, right? So here, children, the rule is this, that if n is even, right, then if you talk about the middle term, then the middle term is going to be given by t n upon 2, right? As n is even, when you divide it by 2, obviously you will get it from the set of natural numbers, right? And to that, when you add 1, again, that is also going to be from the set of natural numbers. This is when you have n to be an even number. So obviously, for sure, n plus 1 is going to be odd, and then this concept that I told you is going to be applicable, right? Now next, let's quickly discuss this once more so that if there is any confusion, all of that gets cleared. Now let's say we have an odd number of terms. For that matter, I have kept a small number of odd terms, right? Let's say now we talk about 5 terms which are all arranged in order, and now you're going to find out the middle term. So you will remove the first 2 terms from the beginning, you will remove the last 2 terms from the end, and the term which is at the center is going to become the middle term, right? For that matter, always remember that is when we have a total number of terms which is odd, then only one term is such that it is going to become the middle term. However, if the total number of terms is even, then you're going to have two middle terms, right? So here, as such, you've seen that if you talk about the third term then becomes the middle term, right? And that here in this case is 3. Now we are trying to find out a formula to find out the value of the middle term if we talk about a binomial expansion, right? Now let's say we have all the terms of a binomial expansion and the binomial expansion be x plus a raised to the power n. Since we know that the total number of terms when we talk about x plus a raised to the power n is going to be n plus 1, so if n is even, then n plus 1 is going to be odd. And then in that case, if we talk about the middle term, children, then that is going to be t n upon 2 plus 1. Since n is even, obviously n upon 2 will be from the set of natural numbers, and to that when you add 1, you will have got the middle term, right? So this is the case when the n, or the highest power, is actually from the set of even numbers, right? Now after this, children, we come to the second case, that is if we talk about the value of n to be an odd number. So next is, if n is odd, then how do you find out the middle term? Like I've already told you that when we talk about a binomial expansion, we are now going to have two middle terms because the number of terms in this case is going to become even. Since we are talking about the expansion of x plus a raised to the power n, n in this case is an odd number, so the total number of terms is going to be n plus 1, which will become even. And as it is even, we will be having two middle terms. For that matter, let us quickly try and consider that if we have a simple sequence of numbers where the total number of terms is even, how to find out the middle terms. Now, for that matter, let us consider that we have 10, 20, 30, 40, 50, and 60. These are those numbers which are in order, and as you see, they are an even number, right? So you have 1, 2, 3, 4, 5, 6. So this is the total number of terms which is even. Now, in order to find out the middle term, what you require to do is you will now require to segregate two terms from the beginning, two terms from the end. As such, you will be left out with two middle terms, which in this case is 30 and 40, right? So here, contrary to when the total number of terms was odd, where you had one middle term, when the total number of terms is even, you will be having two middle terms, and this is what you require to remember. Now we can consider a bigger case. If suppose the total number of terms, we say a big number like 10, right? So 10 is the number of terms, right, of say any sequence, and if we require to find out the middle terms as the total number of terms is even, one thing is for sure that you know that the number of middle terms that you will be having will be 2. So you will have to remove an equal number from the beginning, an equal number from the end, in order to get to two middle terms, right? So here, children, if say we remove 4 terms from the beginning, we remove 4 terms from the end, then we'll be left out with 2 terms at the center, which will be the 5th term and the 6th term, right? So these two will then become the middle terms. For that matter, now let's talk about a binomial sequence. So we talk about the expansion of some x plus a raised to the power n, right? And now the case that we are considering is, children, that if n is odd, right? So like we discussed, we're going to have two middle terms. So now we're going to talk about these middle terms. So middle terms are going to be 2 in number, like we discussed. And when we talk about the first middle term, children, that is then going to become equal to t of n plus 1 divided by 2. Now why is this n plus 1 divided by 2? Because here when we talk about n actually is odd, and that's why we have n plus 1, which is the number of terms of any binomial expansion when the highest power is n, is going to be a even number, right? So n being odd, when you add 1 to it, then it is going to become an even number, right? And now when it becomes an even number, then again you're going to use the same process like we discussed earlier here, right? And if you talk about the middle terms, then what you're going to do is you will add 1 to this value of n, which is odd, right? And if you divide it by 2, then as n plus 1 is even, right, you will get the ratio to be from the set of natural numbers, and this, children, is going to give you one of the middle terms. Except that, children, if we talk about the other middle term, then remember that is going to be t n plus 3 divided by 2. Now let us do it for this case that we had at hand. So we had 6 numbers, remember, right? So if we talk about a binomial expansion, obviously the highest power must have been 5, right? So the value of n being 5, if we talk about the value of n plus 1, it will become equal to 6, and when we divide 6 by 2, we're going to get 3. And if you watch it, here we have the third term, which becomes one of the middle terms. And similarly, when we talk about n plus 3, it is going to become equal to how much? 5 is the highest power. 5 plus 3 will become equal to 8. When divided by 4, it will then become equal to 4. So the fourth term will become the other middle term, which is what we have here, right? So this is, children, the gamut of formulae that we have for finding out the middle terms. I'm sure you people must have understood this, right? That is, when we talk about n to be even, then the total number of terms will be odd, and then the middle term will be given by t n upon 2 plus 1. And if suppose we talk about n to be odd, right, then obviously what will happen is we will have the total number of terms to be even. It'll be something like this, that we have 6, say, to be the total number of terms. 2 terms from the beginning will be removed, 2 terms from the end will be removed. As such, we'll be left out with 2 terms at the center, and this will happen for any even number of cases, alright? And in that case, children, as we can see here, we will be getting 2 middle terms, which can be found out by finding out t n plus 1 upon 2 or t n plus 3 upon 2. So these two will then give you the 2 middle terms. Now I'm sure you people must be clear about how to find out the middle terms. For that matter, perfectly sure about which are going to be the middle terms, right? Tayyab, are you all clear about this? Sure. Okay, now children, we will be discussing a sum, and that will make the concepts more clear. So this, children, is the first sum that I have for you people here. Now give it a try, and I'll be giving you some 10 seconds for trial, after which I'll be discussing the sum with you people. Okay, now children, let's discuss the sum. I'm sure you must have given it a valiant try, and now you are ready how to look up the solution of the sum. And if it matches, I'm sure you're going to be very happy, as you've been able to do the sum without any supervision. Now here, children, we get to see that we have the expansion of x upon 3 plus 9y, which is raised to the power 10. Right? So if you talk about the number of terms that we're going to have, that will be 10 plus 1, and as you see that is an odd number, right? And when we have an odd number of terms, then I'm sure you remember by the formula that if we talk about the middle term, right, that is what we have to find out. That is going to be 1 in number, and the middle term, children, is going to become equal to t n upon 2 plus 1, right? Now here, children, as you see, the value of n is 10 here. So when we talk about the middle term in this case, we will now have got t 10 upon 2, and to that we're going to add 1. So that, children, is then going to become equal to t 5 plus 1, or in other words, it is the 6th term, which is going to be the middle term, right? So in order to find out some tr plus 1, I'm sure you people remember a formula, that is tr plus 1 in the expansion of x plus a raised to the power n becomes equal to ncr x, that is the first term, raised to the power the difference of the superfix and the suffix, and the second term a raised to the power the number which is there in the suffix, that is r. So as such here, now that we have to calculate the value of t10 upon 2, that is t5 plus 1, it will become equal to n, which is 10 c5, the first term, that is x upon 3 raised to the power the difference of the numbers in the superfix and the suffix, that is 10 minus 5, times of 9y, which is just like a in the conventional binomial, raised to the power the number which is there in the suffix, which is 5, right? Now if you calculate this, you will have got the middle term. So this, children, is going to become equal to factorial 10 divided by 10 minus 5 factorial times of factorial 5, and further that is going to be multiplied with x upon 3 raised to the power 5 times of 9y also raised to the power 5, right? So for the children, this can then be written as factorial 10, right? That can be written as 10 into 9 into 8 into 7 into 6 into factorial 5, which is going to be divided by factorial 5 and further multiplied with factorial 5, where factorial 5 is going to get cancelled, and further then we have x raised to the power 5 divided by 3 raised to the power 5, and further then we have 9 raised to the power 5 times of y raised to the power 5, right? And then we further are to simplify this. I'm sure you can see that factorial 5 will get cancelled from the numerator and from the denominator, and then we can now write this factorial 5 in the denominator as numbers from 5 to 1, right? So thus we will now have 10 into 9 into 8 into 7 into 6, which is going to be divided by 5 into 4 into 3 into 2 into 1. Now children, you get to see that 5 into 2 is 10, which will get cancelled with 10, and then after that we have 3, which will cancel 6 2 times, and then we have 4, which will cancel 8 2 times. As such, now we will have the product of all of this to be 9 into 2, which is 18, into 2, which is 36, which is further to be multiplied with 7, right? Better will be if we multiply 9 and 7, which will give us 63, right? And then further we multiply it by 4, right? Next then, children, we have x raised to the power 5, which will be kept as it is, right? And then further after that we now have next here this to be divided by 3 raised to the power 5 and further multiplied with y raised to the power 5, and 9 raised to the power 5 can obviously be written as 3 raised to the power 2, right, which is 9, and whole raised to the power 5, and children, this is going to become equal to 3 raised to the power 10, right? So this is what we write here now. As such, some powers of 3 also are going to get cancelled, and thus we will now have here 4 3s are 12, 1 remainder, 4 6 are 24, and 1 is 25, so 252 times of x raised to the power 5. All the powers of 3 from the denominator will get cancelled with the powers of 3 in the numerator, and now we will be left out with 3 raised to the power 5 in the numerator, and that, children, is going to become the final answer, although you can even multiply 3 raised to the power 5 with 252 to get to the final answer. Right now, children, what we are going to do is we will now be discussing here the sum all over again. Right now, children, discussing the sum all over, because I'm sure you people might be having some sort of confusions, which I'm sure to clear by the second explanation. Now in the question, children, you've been given here that we now have to find out the middle term in the expansion of x upon 3 plus 9y raised to the power 10. I told you people, children, that if we have the highest power of the binomial to be 10, or for that matter, if you talk about n, we have it to be 10, then the number of terms is going to become equal to 11, that is n plus 1, right? So here children, if we are to find out the middle term, then that is going to become equal to t n upon 2 plus 1. This is when we talk about the case to be n to be even, right? Do remember this. Then after that, we now talk about writing this in terms of what values we have. So we are now going to have it to be t10 upon 2 plus 1, right? t10 upon 2 children is going to become equal to t5 plus 1, and whenever we've got to find out the general term, right, then the general term in the expansion of x plus a raised to the power n is given by tr plus 1 is equal to NCR x raised to the power n minus r a raised to the power r, right? So here we substitute in this the value that we have in accordance with this question. So as the value of n is 10, so we will now have 10c5 because we require to find out a term where the value of r is 5, times of the first term, which is x upon 3 raised to the power the difference of the numbers in the superfix and the suffix, that becomes equal to 10 minus 5, times of 9y raised to the power the number which is there in the suffix, that is 5, right? Now further children, we have to simplify this, and we've done multiple number of terms, right, where we've done the simplification this way. That is, if we talk about this factorial 10, right, it is the numerator, right, which can be got when we find out the value of 10c5, and then further when we talk about the denominator, it will come to be the product of two factorials, one being the difference of the superfix and the suffix, and the other being the number in the suffix, right? So as such, here we will now have factorial 10, which is going to be divided by factorial 10 minus 5 times of factorial 5. So the factorial 10 can be written in terms of 10 into 9 into 8 into 7 into 6 into factorial 5, which will get cancelled with the factorial 5 in the denominator, and the other factorial 5 can be written as 5 into 4 into 3 into 2 into 1. So 5 into 2 gets cancelled with 10, then we have 4 getting cancelled with 6, such that we are left out with, or rather 4 gets cancelled with 8 2 times, and 3 gets cancelled with 6 2 times. Then we have 7 into 9, which is 63, which requires to be multiplied with 4. So we have 4 3s are 12, 1 remainder, 4 6 24, and 1 is 25. And then children, we multiply this with x raised to the power 5 and divide this with 3 raised to the power 5, and further multiply it with y raised to the power 5, right? And 3 raised to the power 2 is how we can write 9, which is raised to the power 5. As such, we will have 3 raised to the power 10, right? Now children, 5 powers of 3 are going to get cancelled from the numerator and from the denominator, because we have a rule children, that is, if we talk about some a raised to the power m divided by a raised to the power n, then that becomes equal to a raised to the power m minus n, right? So using this, now we will have 5 powers of 3 to be vanishing from the numerator. And now if you find out the product of all of this, this will give you the middle term in the expansion of this x upon 3 plus 9y whole raised to the power 10. So is everybody clear about all of this? Kabir? Sure? That's good. Okay, now children, after this we will now be discussing the next sum, that is this. Quickly give it a try. I will be giving you some time for trial, after which we will be discussing the sum. Okay children, now let's discuss the sum. In the question we've been given here that you've got to find out the middle term in the expansion of 3 minus x cube upon 6 raised to the power 7. Now one thing that you watch here is that the value of n is 7. As such, the total number of terms is going to be 7 plus 1, which is 8. So if you talk about the total number of terms to be 8, we know that we will now be having two middle terms in this, right? So in order to find out the middle terms, we will now talk about one of the middle term to be what? It is going to become equal to t 7 plus 1 divided by 2, and the other is going to be t 7 plus 3 divided by 2, right? So that then is going to become equal to t 8 upon 2 and t 10 upon 2, right? So thus we will talk about finding out the fourth term and the fifth term, which will be the two middle terms, right? And that, children, is a child's play for you people, as you know that the general term is given by what? It is given by tr plus 1, right? And that is given by, in the expansion of x plus a raised to the power n, ncr x, that is the first term, raised to the power the difference of the superfix and the suffix, that is n minus r, and the second term, that is a raised to the power the number which is there in the suffix, that is r, right? So this, children, is going to be the general term, right? And here, using this, we will now find out t4 and t5, right? So if we talk about t4, children, obviously that can be written as t3 plus 1, right? And t3 plus 1 is going to become equal to n, which is 7 here, c3 times of x, which is the first term, that is 3 raised to the power the difference of the numbers and the superfix and the suffix, which will become equal to 7 minus 3, that is 4, multiplied with the second term, that is minus x cube upon 6, whole raised to the power the number which is there in the suffix, that is 3. Now next, children, we will expand this, and that's pretty simple, as this is going to become equal to factorial 7 divided by factorial 7 minus 3, that is factorial of 4, further multiplied in the denominator by factorial of the suffix, which is 3, and then we have 3 raised to the power 4, as minus is raised to the power 3, which is an odd number, so we will have minus 1, right, which will be multiplied with this whole term. And then we'll have x raised to the power 3, which is further going to be raised to the power 3, and in the denominator we can write this to be 3 into 2, which is 6, which will also be raised to the power 3. So now we can do a little bit of simplification. So as there is a minus sign, so that minus sign can be popped up at the beginning of the term. Then factorial 7 can be written as 7 into 6 into 5 into factorial 4, and then in the denominator we have factorial 4, which is going to be multiplied by factorial 3, and then we can talk about this factorial 3 to be written as 3 into 2 into 1. Now factorial 4 will get cancelled from the numerator and from the denominator, and then we will just be left out with 3 into 2 in the denominator, which will cancel 6 from the numerator, and then we will have 7 5s is 35, so we'll have minus 35. And now further we talk about the rest of the terms, as we find that we have 3 raised to the power 4 in the numerator, and in the denominator we have 3 raised to the power 3, so as such we will just be left out with 1 3 in the numerator, and then we have x raised to the power 9, as here the rule that is applicable is a raised to the power m whole raised to the power n will become equal to a raised to the power m into n. Now next, children, after this what we do is we now have here 3 into 2, right? So 2 still is left, and thus we will now be talking about in the denominator 2 raised to the power 3, which is going to be left out, right? So these numbers, children, we are going to write here as such. Now we have here 3 times of x raised to the power 9, which is also going to be divided by 2 raised to the power 3, which is 8, right? And that is about all that we had in this term. So now further we multiply 35 with 3 more, so 3 and 5 is 15, 1 remainder, 3 3 9, 1 is 10, so that becomes equal to minus 105 divided by 8 times of x raised to the power 9, and that, children, will become the middle term, right? rather one of the middle terms. Now after that we'll be talking about the other middle term. So as we've seen above here, the other middle term is going to be the fifth term, right? So next now we'll be talking about the other middle term, which now children we can write by writing t5, and t5 can thus be written as t4 plus 1, right? Now when we talk about t4 plus 1, guys, then here in the expansion of this series or this binomial which has been given to us, which is 3 minus x cubed upon 6, right, whole raised to the power how much? Whole raised to the power 7. So now we can write this term as it is now going to become equal to 7c4, right? The first term is 3. So we have 3 raised to the power, the difference of the numbers in the superfix and the suffix, that is 3, times of we have minus x cubed upon 6. So we have minus x cubed, which is divided by 6, and whole raised to the power, we will have the number which is there in the suffix, that is 4. Now further children, we have to simplify this. So further to simplify this, what we do is we can now write this as 7 factorial divided by 7 minus 4, that is factorial 3, to be further multiplied with factorial 4, as you find that that is exactly the same as the factorial that we found out in the last case, that is 7 factorial divided by 4 factorial into 3 factorial. So whatever what was its value is what we can write here, that is 35, right? So as such we can write the binomial coefficient here to be 35, right? And now we have further here 3 raised to the power 3, right? And since we have here minus 1 which is raised to the power 4, that is going to become equal to plus. As such we won't change the sign of this term. Next then children, we have x raised to the power 3 whole raised to the power 4, that will become x raised to the power 12 by applying the rule of indices. That is, if we talk about some a raised to the power m which is whole raised to the power n, then that becomes equal to a raised to the power m into n. Next after this, when we talk about the denominator, we will now have 3 into 2 which becomes equal to 6, which is whole raised to the power 4, right? And except that we also have 3 raised to the power 3. So as such we will do a little bit of cancellation. So we have 3 raised to the power 4, which can be written to be multiplied with 2 raised to the power 4, right? And except that we also have some powers of x, that is 12, and that is about all that we have to write. Now further we will just do a little bit of simplification. We have the powers of 3 which can be cancelled off, so we'll be left out with 1 power of 3 in the denominator, and we'll also be left out with 4 powers of 2, right, because it doesn't get cancelled with any power of 2 as it's not there. And further we multiply that with x raised to the power 12, which has already been written, and this children is going to become your final answer. More simplification in this can be done, but it is not required. If you just write it this way, then you would have written your answers correctly. So here children, we have 2 middle terms. One middle term was this that we found out, and the other middle term is this that we just found out. So these are the 2 middle terms which will give you your final answer. So now children, I'll just quickly be discussing this all over. In the question you've been given here that you're going to find out the middle terms in the expansion of 3 minus x cubed upon 6 whole raised to the power 7. Now like in this question, there is a confusion which has been popped up that find the middle term. Then probably you will think that probably there should be just one middle term. How come you are thinking that there have to be 2 middle terms? So that is just to bring up a little bit of confusion. Here in this case, as the total number of terms is going to be 8, which is an even number, and like we've discussed, when the total number of terms is even, there will be 2 middle terms. So make sure you find both the middle terms and cancel off all the confusion which has been unnecessarily popped up. Sometimes we teachers do that, right, so that you people think a little more. Now, in order to find out the middle term in the expansion of 3 minus x cubed upon 6 raised to the power 7, the total number of terms in this is going to be 8. As such, the middle terms are going to be two in number, that is one is going to be t7 plus 1 upon 2 and the other is going to be t7 plus 3 upon 2, right? Obviously here we are using this that the middle terms are tn plus 1 divided by 2 and tn plus 3 divided by 2 as per the formula. Now when we calculate this, this comes to the fourth term and the fifth term. Now if you talk about the general term in the expansion of x plus a raised to the power n, then that becomes equal to tr plus 1, which is given by ncr, the first term x raised to the power n minus r times of the second term a raised to the power r, right? So here we will be talking about the fourth term to be written as t3 plus 1, which thus is going to become equal to 7c3 times of the first term 3 raised to the power the difference of the superfix and the suffix, that is 4, times of the second term, which is minus x cubed upon 6 raised to the power 3. Right now, children, here further we just simplify this by writing 7 factorial to be 7 into 6 into 5 times of factorial 4, which gets cancelled with the factorial 4 in the denominator. Then 3 into 2 becomes equal to 6, which gets cancelled with the 6 in the numerator. And then further we are just left out with 7 into 5, which becomes equal to 35. And then we can cancel off some powers of 3 2, as we have 3 raised to the power 4 and 3 raised to the power 3. So as such, we are just left out with 1 3 in the numerator, and we have 3 powers of 2 which are left out in the denominator. And except that, applying the rule a raised to the power m whole raised to the power n to be given as a raised to the power mn, we have x raised to the power 9 here, which also is going to be part of the answer, right? Similarly, children, we also have to find out the other middle term, which we just calculated to be the fifth middle term, and that thus is going to become equal to t4 plus 1, and thus by the formula of the general term we will have it to be 7c4, the first term 3 raised to the power the difference of the numbers in the superfix and the suffix, that is 3, times of the second term, which is minus x cubed upon 6 raised to the power the number in the suffix, which is 4. Right? And further, children, we do a little bit of calculation as we find that the binomial coefficient is exactly the same, that is factorial 7 divided by factorial 4 into factorial 3. So we keep its value directly to be 35 as we calculated it earlier, and since we have minus raised to the power 4 here, so obviously the sign with this term is going to be plus. And then here we have x raised to the power 12, and further we can cancel off some powers of 3, that is only 1 power of 3 in the denominator is going to be left, right? And we have 4 powers of 2 also, which is going to be left, and the multiplication of all of this will give you the final answer. So is all of this clear with you all? For sure. Amritansh? For sure. Okay guys, that's all for now then. Make sure you practice all of this and make these your strong sums, right? Bye for now. Have a nice time. Do your practice. Bye.